Today we will discuss implicit differentiation. So let's start with the graph of the relationship given by x squared y plus y squared minus x cubed equals 1 in the first quadrant. It's a nice smooth curve, and you might ask the question, what are the tangent lines? And the point 1, 1 is on this relationship, and you can ask the question, what's the slope of the tangent line to this curve at the point 1, 1? The graph of this relation defines a function y equals f of x in the region pictured. You can see this is the graph of a function, and the slope we want is y prime for that function. But we don't have an explicit formula for the function, which is the problem. The function y equals f of x is defined implicitly by the equation x squared y plus y squared minus x cubed equals 1, and we'd like to find this slope without actually explicitly solving for the function. So, relationship, what's the slope of the tangent at the point 1, 1? Let's look at a slightly different problem. Suppose that we wanted to differentiate the term x squared f of x, where f of x was not specified. We'd use the product rule, and the product rule would give us derivative of the first, which is 2x, times the second, f of x, plus the first, x squared, times the derivative of the second, f prime of x, where we don't know what f and f prime are. Suppose we also wanted to differentiate f of x quantity squared. Now, this is a composition of functions. The chain rule tells us that the derivative would be, well, the outside function is a squaring function, so 2 f of x to the first times the derivative of the inside function f of x, f prime of x. Now, what does that have to do with our problem? Well, the answer is this term and this term can be treated exactly that way if we think of y prime as f prime of x and y as f of x. So let's start in. What we're going to observe here is the equation x squared y plus y squared minus x cubed equals 1 says the left-hand side and 1 are equal as functions of x. Okay, not just at a single point, but as functions of x, and thus their derivatives with respect to x are equal. So we take the derivative of both sides. The x squared y term, by the product rule, becomes the derivative of the first, 2x, times the second, y, plus the first, x squared, times the derivative of the second, y prime. Next, we take the derivative of y squared, which is a composition of functions as we've seen before, and we get 2y to the first times y prime. The derivative of x cubed is minus 3x squared, and of course, on the right-hand side, the derivative of 1 is 0. So here's our expression, and now what we're going to do is solve for y prime. We start by isolating y prime on the left-hand side. Okay, so what we're going to do is we're going to take the 2xy term, move it over here. We're going to take the minus 3x squared term. We're going to move it over here, and we get the following. Now what we're going to do is factor out a y prime from the left-hand side. And finally, we divide through by the x squared plus 2y to solve for y prime. And here's an expression that gives us y prime, but it's an expression involving both x and y. Okay, so y prime in principle should just be a function of x. Our answer for y prime involves both x and y, but that's not a problem because we know what x and y are at this point. They're 1, 1. So we just substitute that into the expression. 3 times 1 squared minus 2 times 1 over 1 squared plus 2 times 1, and we end up with 1/3, which is in fact the slope of the tangent line. Let's do a different example. X squared y squared plus cosine 3x plus 2y equals 7. We want to find a general expression for y prime, and we're going to play the same game. The derivative of the left-hand side with respect to x is the derivative of the right-hand side. We will be using Leibniz notation here. So instead of y prime, you're going to see dy dx. So starting here, it's a product rule. Derivative of the first 2x times the second y squared plus x squared, the first, times the derivative of the second. And this is a chain rule, which we've seen before. So we're going to get a 2y dy dx. Next, we look at this term. This is very clearly a chain rule. Derivative of cosine is minus sine. So it's minus sine of 3x plus 2y. Now times the derivative of 3x plus 2y. And the derivative of 3x is 3. And the derivative of 2y is 2 dy dx. And that's going to equal the derivative of 7, which is 0. Now, before we isolate dy dx, we're going to have to multiply out this term because it consists of two pieces, one of which has a dy dx, the other doesn't. So after we do the multiplication, we pick up a 3 times this sine term minus that same sine term times 2 dy dx. Now we move all of the stuff that doesn't have dy dx's onto the right-hand side, which is this term that goes over as a plus, and is this term, which goes over as a minus. We factor out the dy dx from the left-hand side, and we just divide through. And here is our expression, complicated as it is, for dy dx, which is valid at any point xy that lies on this curve. Let's do another problem. Let's find the equation of the tangent line to x squared square root of y plus y to the fifth equals 2x plus 4 at the point minus 1, 1. We look at this expression, which we're going to differentiate, x squared times y to the 1/2. So we get derivative of the first, which is 2x times the y to the 1/2, plus x squared times the derivative of y to the 1/2. And that's a chain rule. We're going to get a 1/2 y to the minus 1/2 times the derivative of y, which we're writing as y prime. Next term is y to the fifth. Chain rule again. 5y to the fourth times the derivative of y, which is y prime, equals the derivative of the right-hand side, which is just 2. Now, what we're going to do this time is instead of solving involving x's and y's, we're going to put in the information about what x and y are, which will make the calculation easier. So this becomes 2 times minus 1 for x times 1 to the 1/2 for y equals 1 squared, which is 1 times 1/2, 1 to the minus 1/2 times y prime, which of course we don't know, plus 5 times 1 to the 4th times y prime equals 2. And now when we simplify that, this term just becomes minus 2. This is 1 times 1/2 times 1 to a power is 1. So this is just a 1/2. This is a 5 times y prime equals 2. Now you move the minus 2 over here. And you notice that 1/2 y prime plus 10/2 y prime is 11/2 y prime. So you've got 11/2 y prime equals 4. And now when you multiply both sides by 2/11, the reciprocal, you get y prime is 4 times 2/11, or 8/11. Now we're going to find the equation of the tangent line, and the point formula will tell us that. Y minus y naught equals mx minus x naught. And x naught and y naught are minus 1 and 1. And m is 8/11ths. So we get y minus 1 equals m 8/11ths x minus 1 or x plus 1, and that's the equation of the tangent line. Finally, let's calculate a second derivative implicitly. So we have the relationship x squared plus y squared equals 4, and we want to calculate y double prime implicitly. We start by implicitly differentiating this expression, and we get 2x from the x squared. We get plus 2y y prime, again for y squared, and the derivative of 4 is 0. And now what we're going to do is move the 2x on the right-hand side, divide through by 2y. The 2's cancel, and we get y prime is minus x over y. Now what we want is y double prime, so what we're going to do is we're going to differentiate this expression with respect to x. And what we're going to get is y double prime, because the derivative of y prime is y double prime. And here we get a quotient rule. Okay, so denominator times derivative of numerator minus numerator times derivative of denominator over denominator squared. Now the problem is we got a y prime floating around, but we know what y prime is. So we're just going to substitute for it using this expression. And we get y times minus 1 plus x times, now we've substituted in for y prime, the minus x over y squared. Now what we do is there's a negative here, there's a negative here, we factor that out in front. Now we want to clear this denominator in the top, so we multiply top and bottom by y. We pick up a y squared plus x squared over y cubed. And now x squared plus y squared is 4. So this x squared plus y squared gets replaced by a 4, and our final answer is minus 4 over y cubed.